Hello, sixth grade. This is Mrs. Froman, and we're going to take notes on Chapter 2, Section 1 in your environmental science book, and that's on energy flow in ecosystems. So the energy role of the organisms is determined by how it obtains its energy and how it interacts with other living things. So if it's something called a producer, that's something that makes its own food. They use gases or light from the sun for their energy. So these would be like all the plants. Some bacteria do this too. So those would be the producers. They make their own food. They don't have to eat anything else to get their food. They use the energy from the sun or some other gases to get that. A consumer depends on those producers for food. So they either eat the actual producers, so they're eating the grass and the plants, or they eat other organisms, so they're eating the organisms that are eating the grass and the plants. So if it's an herbivore eats only plants. That's all it's going to eat. If it's an omnivore, it eats plants and animals. A carnivore only eats animals, and a scavenger eats dead organisms, so that's cleaning up all the dead stuff. Then there's something called the decomposer. The decomposer breaks down waste and dead organisms and then returns those raw materials back to the environment. So things that are decomposers are the bacteria and fungi. So it's breaking those things that have died down into tiny little atoms and molecules and putting those back into the ecosystem to be used in other things. So they're kind of the recyclers. A food chain is a series of events where one organism eats another organism to get energy. So a producer makes its own food, and then the animal that eats the producer is called the first level consumer, because that's the first thing that's eating the plants. Then the animal that eats the first level consumer is called a second level consumer, and it kind of moves up from there, but we're only concerned about first and second level right now. Now the thing to remember, life is not simple. It's not just a simple little chain where you have this animal eats that animal and that animal eats that animal. Most of them are parts of many food chains. So it's called a food web because by the time you connect everybody who's eaten everything, it makes almost like a spider web. So we call that a food web. So here's an example. So here's the food chain. So we have the grass, the mouse eats the grass, the snake eats the mouse, the hawk eats the snake, and then the decomposers, once all of those die, they decompose all of that. It's really not that simple because the mouse is probably eating other things besides the grass, the snake is probably eating other things besides just mice, and the hawk is definitely eating more things besides just a snake. So when we look over here to the food web, you see it gets a little messier, but when we start down at the bottom, we still have plants. We have a grasshopper eating the plants, we also have a squirrel eating the plants, and the mouse eating the plants. Then we have the frog eating the grasshopper, but then the mouse also eats the grasshopper. And then we have a rabbit here, which is also eating that plant. And then the farther up you get, the more messy it gets. The fox is eating the mouse, and it's also eating the squirrel, and it's also eating the rabbit, and the owl eats the frog, and the snake eats the frog, and the owl eats the snake. So a food web is a little more realistic in an actual ecosystem. Then we have something called an energy pyramid, and this shows the amount of energy that moves from one feeding level to another. So it's not really what eats what, but how much energy is transferred from the plants to the animal that eats the plants. So the thing to remember is some energy is used by the organism at every level. So you have to use some energy for your life processes. So even plants use some of their energy that they make for their own, to keep their own cells going and grow their roots and things like that. So producers have the most energy available because they're making their own food. So they have a lot of energy that's available to give to the next level. But only about 10% of that energy is transferred to the next higher level. Doesn't matter which level you are at, only 10% of that energy will be moved up, because 90% of that energy is used for the life processes, or when you get into like mammals that make their own body heat, a lot of that's lost as heat. So that results in fewer organisms at the higher level. So when you look at just at the African plains, when the lion's at the top, there's not very many lions, but there's a whole lot of gazelles, because the lions need to eat a lot of gazelles to get the energy that they need, because they're only getting 10% of the gazelle's energy when they eat that gazelle. All right, so here's an example of an energy pyramid. So they actually put numbers on here so you can see how 10% moved up. So we start with the producers that have 1,000 kilocalories, and that's just a measurement of energy. So we start with that 1,000 kilocalories. When the grasshopper eats the grass, they only get 100 kilocalories of the energy that the grass had to begin with. Then when these little shrews, which are called, we have our secondary consumers, the shrews eat the grasshoppers, the shrews are only getting 10 kilocalories, because that's only 10% of 100. So 90% of that 100 kilocalories is used by the grasshoppers just in order to live. Then when we get up to what's called the tertiary consumer, up here with the owl, that eats the shrew, but it only gets 1 kilocalorie of energy from each shrew that it eats, because again, the shrews are using most of that energy for their life processes. All right, so that's it for the notes. Don't forget to do your quack, and we will talk about it in class. Bye.